Wind is a natural phenomenon here on Earth caused by uneven heating of our surface. Air above the land is heated, causing it to rise. The cooler air over the water moves in, taking its place. This cycle keeps happening over and over. The sun heats the Earth, so we constantly have wind. You've observed wind energy your whole life. As a species, we've used wind energy to grind our grain and travel the oceans. Now we're harnessing wind energy to power our homes. Let's try putting wind to work on a smaller scale. Print out the wind blade template and cut out the whole square. Cut from each corner of the square towards the outside of the center circle. Fold every other flap towards the center and tape it in place. You'll end up with a paper pinwheel. Whee! Put a glob of hot glue onto the back of the pinwheel. Hold the coffee stirrer in place, perpendicular to the back of the pinwheel until the glue cools. Cut the drinking straw to 8 centimeters. Tape the drinking straw to the top of the large cup. Use an optional push pin to keep the rotor spinning smoother. Insert the coffee stirrer rotor into the drinking straw stator. Fasten a binder clip to the back of the rotor. Test that your windmill spins freely either outside in your backyard or with a fan. By definition, power is the ability to do something or act in a certain way, especially as a faculty or quality. This undescribed something is the ability to lift something, stretch something, or move something. So in simpler terms, power is energy used over time. In fact, that simple definition describes the equation for power. Power, measured in watts, is equal to energy measured in joules divided by time in seconds. The energy in the numerator depends solely on how that energy was used, whether you lifted something, stretched something, or moved something. Cut a piece of thin string longer than a meter and then tape it to the back of the coffee stirrer or clip it on with the binder clip. Tie one paper clip to the other end of this string. Make sure that your windmill hangs far enough off the table so the paper clips can move straight up. Once you found the maximum amount, measure the height it was lifted and the time it was lifted. You can measure the total mass using a scale at home or assume that each paperclip has a mass of 0.001 kilograms. Now that you've tested and collected data, it's time to calculate the power rating of your windmill. Let's pretend a windmill is able to lift a maximum of 0.018 kilograms to a height of 1 meter straight up in the air. If it takes 9 seconds for the paper clips to be lifted, what is the windmill's power rating? It's asking you to calculate power, so you might jump straight into the power equation. We know that it took 9 seconds for the paper clips to be lifted, but we have no idea how much energy was used. The energy was used to lift the paper clips straight off the ground. At their highest height off the ground, the total amount of gravitational energy was applied. We need to calculate the total gravitational potential energy before we do anything else. I'm going to start out by writing out my given information. I know that I'm solving for power. I know that first I need to solve for gravitational energy. I'm given the time, I'm given the mass, and I'm given the height. These would all be measured during the activity. Here's our basic gravitational potential energy formula. 9.8, the gravitational force constant of Earth, times the mass of the object, in this case the paper clips, times x. This is the height, the distance that the paper clips were displaced. I write out my formula so I can substitute in directly below. 9.8 remains 9.8. The mass is 0.018, or about 1 gram per 18 paper clips. It traveled 1 meter straight up. Now I'm just going to multiply everything together because it's order of operations. So it took about 0.176 joules of energy to lift those paper clips up. That means that if the paper clips fell, they would start with a potential energy of 0.176 joules. Once you have the energy, you can find the power. We know that power is energy divided by time. In this case, any type of energy. We have gravitational potential energy. I'm going to plug in my energy. I'm going to plug in my time. A quick calculation gives me a power rating of 0.02 watts. With some magnets and copper wire, you can generate electricity using these same concepts. These massive wind turbines have average power ratings of 2 or 3 megawatts. That's about 150 million times more powerful than the windmill you just tested. You'll often see these behemoths along the side of highways or even off the shore. As technology improves, these wind turbines can become more efficient and more effective at turning that wind energy into electricity. That's why it's so important for you to make and tinker now, so you can be part of the next generation of makers, tinkerers, engineers, and innovators. This video was produced with special thanks to the U.S. Department of Energy, the National Renewable Energy Lab, and the Wind for Schools program.